A soil mass in general is composed of three kinds of matter: solids, liquid and gaseous. Solids can be mineral or organic matter or both. These solids can be of different sizes and shapes, and because of it they enclose empty spaces. These empty spaces are called pores or voids. These voids in the soil particles are either filled by liquid, which is generally water, or by gases, which is usually air, or by both, partly by water and partly by air. If voids are not occupied by water, then they are occupied by the air, at least on Earth. But why we are studying this obvious thing? Because the proportion of solids, water and air in a soil mass influence its physical properties. And before founding a structure on the soil, we should study it in detail. Now let's show this soil mass with its constituents separated. Though different phases present in the soil mass cannot be separated, but it will be helpful in understanding the soil behavior and deriving its properties. We imagine these constituents occupying separate spaces. Volume of solids in the soil mass is marked as Vs, volume of water as Vw, and volume of air as Va. This diagrammatic representation of different phases in soil mass is called phase diagram. This kind of diagram represents partially saturated soils in which voids are partially filled with water and rest with air. This diagram contains three phases: solid, water and air. Hence it is called three-phase diagram. When all the voids are filled with water, the soil becomes saturated and the gaseous phase becomes absent from the diagram. Now this diagram contains only two phases, solids and water. It is called two-phase diagram. Similarly, when the soil is completely dry, all the soil pores are empty or say filled with air. Again a two-phase diagram is received. Now from the general three-phase diagram we can say the total volume of soil sample, capital V, is equal to the sum of volume of solids Vs plus volume of water Vw plus volume of air Va. And also the total weight of soil sample W is equal to the weight of solids Ws plus weight of water Ww plus weight of air Wa. But for all practical purposes, weight of air is considered as 0. Hence weight of soil sample is only weight of solids plus weight of water. One important thing to note here is that the term voids is used to include both the filled and the unfilled proportions of the pore spaces enclosed by the soil grains.